Geometry is always beautiful. It challenges your mind and help it grow. Another problem, another challenge. Let's solve it together. We have a large circle with a smaller circle inside it. The two circles are tangent internally at this point. And these line segments represent distances between their boundaries. From this point till here is 10, this point till here is 6, and this distance is 6 too. According to the problem, these lines extend to form the diameter of the large circle and are perpendicular to each other, something that will help us a lot in solving this problem. The first step is to identify what parameters we need to reach the solution faster, and if we don't have them, how we can construct or derive them. Let's define the centers of the circles as O from the large circle here and O prime for the smaller circle. Naturally, we also have two radii. This one is the radius of the larger circle. I show it by capital R. And this one is the radius of a smaller circle. This is exactly where we make the K choice. The advantage here is the radii lie on the same line and we have some value. So it's time to apply the radius relationship strategy. If you look carefully, the smaller diameter from here till here is the larger diameter minus 10. In other words, the larger diameter minus 10 equals the smaller diameter, and we know diameter is 2 radius. So I can write 2 capital R minus 2 smaller r equals 10. Okay, another time, 2 capital R or the large diameter minus 2 smaller r or the smaller diameter equals 10, which simplifies r minus small r equals 5. So the capital R equals small r plus 5. This is the first relationship we get. Welcome to Geomathic. The next step might help you guess the direction we are going to take to solve this problem. If this line is the radius of the larger circle, okay, and we call this point N, then ON equals the capital R or the radius of the larger circle minus 6. So write that. ON equals capital R minus 6. We already know that capital R equals small r plus 5. Let's substitute it to our expression, and this gives us ON equals R plus 5 minus 6. So ON equals R minus 1. I write this here. ON equals R minus 1. Now if you look closely, you will notice that we are forming a right triangle. By connecting the center of the smaller circle or O prime to N, the hypotenuse will be formed, which is equal to R because it's the radius of the smaller circle. We are now just one step away. The value of O prime. Don't worry about how it looks. It's actually much easier than it seems. O prime is the difference between the larger radius and the smaller one. Again, you can see O prime, I mean this segment is equal to the larger radius minus the smaller one. So write that. O prime equals capital R minus R. And again, remember the relationship between capital R and small r. So we have O prime equals R plus 5 minus R, which is equal to 5. So O prime equals 5. The final step has also been completed. Let's move on to the Pythagorean theorem to this right triangle here. The hypotenuse is r, one leg o prime, which is 5, other leg is on, which is equal to r minus 1. I write it here. R squared equals r minus 1 squared plus 5 squared. Expand it. R squared equals r squared minus 2r plus 1 plus 5 squared, which is 25. Then we have this r squared cancel out and 2r equals 26. Then small r equals 13. Capital R equals small r plus 5. Then capital R equals 18. And remember what we want. Shaded area, which here is green. Pi times capital R squared minus pi times r squared. Factor out pi, then we have pi times capital R squared, 18 squared minus r squared, which is 13 squared. If you put the value of pi 3.14, then we have the shaded area equals 486.7. Don't forget to hit the like. Have a good time.